Alright, hello. Damn. Sorry. Alright, we'll get started on the second one. Okay. So, my bad, I was trying to upload that, and this is uploading right now. Page number 2, okay. The first question is, find the exact value of the difference. Okay. Again, cosine 5 pi over 4 minus pi over 6. So if we look at the white sheet that I sent you, the white card, trigonomic identities, call it what? I say the white sheet, I'll call it the white sheet. No, that's identities card, the white sheet, whatever. You look at that, and let's go to sum and difference identities. So cos A plus minus B equals to cosine A cosine B minus plus. So this means the minus plus means if it's plus, it's minus. If it's minus, it's plus. So if it's cosine minus cosine A, this is A, this is B. If this is minus, then it'd be plus. So cosine A cosine B minus sine A sine B. And then we put it in simpler terms. What we're doing is cosine 5 pi over 4 cosine 5 pi over 4, and then cosine pi over 6 plus, not minus, plus, make sure sine 5 pi over 4 sine pi over 6. So then let's go to the unit circle. 5 pi over 4, 5 pi over 4. So we know this is double negative. Okay, so negative root 2 over 2. And then cosine pi over 6, that's, we're solving for the x value. That's root 3 over 2. Plus, not minus, again, plus sine 5 pi over 4. That it's because in the third quadrant it is double negative. Sine pi over 6, that's 1/2 because again sine is y, x is sine equals y over r, and r is always 1, by the way, unless it's explicitly stated. Then x cosine is x over r. That is right. Yeah, and then we'll multiply out. So root 6 over 4 plus negative root 2 over 4, and then you can put it in all into 1, which becomes root 6 minus, or because this is a plus, you're subtracting it, and then you just ignore this, and then it becomes root 2 over 4. Yeah. So again, it's important to know your unit circle. That it's actually very important, and then to know your cosine, sine, how to solve for all of that. Alright, the next problem will be we're going straight down. Okay, an angle in standard position has a measure of 3 pi over 2 radians. What is the slope of the terminal ray of this angle? Okay, standard position has a measure of 3 pi over 2. So, terminal, this is just a bunch of fancy words. The slope is important though. Slope is, you know the Pythagorean theorem, a squared plus b squared equals c squared. And so in order to do this, we need to solve for tangent, and they give you 3 pi over 2. So we're doing tangent 3 pi over 2, and let's go ahead and look at our unit circle. And so when we look at the unit circle, it's 0, negative 1. Tangent is y over x. And so y over x, let's look at this. Negative 1 over 0 is undefined. So this would be undefined C. And this is all fancy talk. All you need to know is measure 3 pi over 2 and what is the slope. Because all of that is just extra material right now. Okay, G of O equals to negative 2 tan 2 theta plus 3. Okay, I'll try to do this without using a thing, without using the graph, but again, so we know what, if you don't know what the tan graph is, this is the asymptote formula plus pi k. So then it kind of like pi over 2 plus pi over 2, 3 pi over 2. This is what a normal thing should look like. I'm sorry, yeah, I'll just show you. Y equals to tan x. This is what a tangent graph looks like. Okay, look, there's a lot of swirls. There's asymptotes. They don't obviously show you the asymptotes. And it's hard. Okay, so gotta cover up the answer. So now that we have it, let's go. Y equals to negative 2 tangent 2 theta plus 3. So this 2 theta equals negative 2 tan plus 3 blah blah blah, or something like that, right? Sorry for the bad handwriting. I'm writing with the mouse. But what we're gonna do is, let's take this out. Wait, no, not really. Okay, how did I do this? Oh, wait. We need to know 2 theta equals to pi over 2 plus pi k. This is the formula for, oh shit, wait. Formula for the asymptotes. Okay, the formula for the asymptotes. So then, in order to get rid of this and make this normal theta, you have to divide both sides by 2. So theta equals to pi over 2 divided by 2 is pi over 4. Pi divided by 2 is pi 2, so we got pi over 2k. This is our slope formula. So this means that you start at pi over 4. Alright. You start at pi over 4. 2x, was that? Yeah. You start at pi over 4, and then the period repeats, the asymptote repeats every pi over 2. And we go back to our tangent equation. We know it's negative 2, and negative means you turn it around. So instead of looking like this, you're going to turn it around like this. It's going to get turned around. And on top of that, you're adding 3. So that means the midpoint that would start usually at the bottom, like over here, the midpoint, it would go up 3. So we'll here, I'll show you. Plus 3, right? You add 3 to the midpoint. So that's how you solve that. Okay, and the next question. Find the value. Okay, find the value of sine A plus, and then they give you. This one was a little confusing. I understand if you don't quite get this, but what we're gonna do is, because we're gonna go take a look at our white sheet. We're gonna look at the properties. We're gonna look for the property that has the right one, and it's the sum and difference identities, because it's sine and then A plus. So this means it is sine A. This is A because it's closer to the y slope, and this is the B, or whatever that is, because it's closer to the B slope. So the sine formula. Oh my god, do I have it? I don't. I have to write it. Sine A cosine B plus, because sine plus cosine A sine B is equal to sine A plus sine A plus B. Oh, why did I put that in parentheses? Sorry. And now that we have this, we plug in, and what it should end up as sine A, which is the y value. The y value of A, we determined this first one was A, the second one is B. Or, I mean, it does technically tell you, I guess, with the round, but negative 0.77 times 0.9, because this is cosine of B, which is the x value. You add it, negative 0.64, and then 0.43. 0.64 is the cosine A. Then sine B is the y value of B, which is 0.43, and you should end up with negative 0.9682. I'm sorry for not being able to show you. I just don't want to draw all that, and I still have another page to get to. Okay. One period of a trigonometric function is shown. Which of the following represents the value of C? Okay. So CD. Oh my god. I'm sorry. Wait, can I can't make this smaller. Can I use Spotify to make this smaller? Can't make Spotify smaller. Fuck. Can I make this smaller? Sorry for the delay. If you can go ahead and skip this if you're watching this live or whatever. Okay. Oh, bro. Okay, whatever. Yeah, you'll see this, but just ignore it and then. Bro, what? Just ignore it for now, and then. I mean, that is the steps, but I have to explain the steps to you. Okay, so C and D, right? So if we look at D, D is the y value of this. We can automatically tell that D is 0.5. And why do we know D is 0.5? We know D is 0.5 because the y value matches up with the 0.5 length on there. You should be able to see on your practice test if this isn't close enough for you. But now that we know 0.5, now what did I do? So now we know sine theta or sine x is 0.5. Sine x equals to 0.5. Okay, great. Now you might be thinking, okay, now what do we do here? So what we're going to do is we're going to turn this to an arc sine. Sine negative 1 0.5 equals to x. And because they're asking which of the following best represents the value, and they gave us a bunch of equations, this should be, or this is sine, if you didn't know, arc sine is equivalent to sine negative 1. Again, I don't think this should be on there, but it's good to know. Arc cosine, are we doing cosine on this one? No. Arc sine pi over 6, are we solving for pi over 6? No, we're solving for 0.5. Arc sine 0.5, that is the correct answer because the y value is 0.5, and we're again trying to solve for x. And in order to solve for x, we need to inverse the equation. Okay, last question for this page. Find the exact value for each. Oh, this is super easy. Where is this? Okay. So this is our, I'm sorry if it's super messy. But basically what we have, A in this equation, do I really have to write this out? Sorry. Sine A is 11 pi over 18, and cosine 7 pi over 18. Now, if you look on your sheet, you'll know we did this previously as well. But if again, it's on the sheet. It's like the Pythag. No, it's not Pythagorean. It's sum and difference identities. So what this really means is that sine, and this is A and this is B. So we can condense this into 11 pi over 18 plus 7 pi over 18. And in order, we can further condense this. This is, they both match up conveniently. 18 pi over 18, which means that this is sine pi. Okay, sine pi. Let's look at your unit circle. Sine of pi is what? Sine of pi is 0, right? Yeah, sine of pi is 0 because sine is the y over r. R is automatically 1 in this unit circle, so you should just be solving for y, and y in this case, y is 0. Okay, next question. This is similar. Cosine pi over 18. Okay, cosine pi over 18, and then cosine 5 pi over 18 minus, sorry for the messy writing, sine pi over 18, and then sine 5 pi over 18. Okay, great. Sine pi over 18, sine pi 5 pi. Now, if you look at the sum and difference identities, this is cosine. We know that this one is backwards, so instead of plus minus, it's minus plus. So this is minus, then it correlates with plus. So this turns into, the parentheses again. I'm sorry. Cosine pi over 18 plus 5 pi over 18, which turns into cosine 6 pi over 18, which then turns into cosine pi over 3. Now it's cosine pi over 3. Cosine pi over 3, now we look at a unit circle. Cosine is x over r, so we're looking for the x value of pi over 3. Now that would be 1/2. We've solved the answer. We got the answer. Tell me if you need, pi 1/2. Great. Oh, how do I stop this? Okay, this is page 2.